Hello everyone, welcome back to the e-learning modules for Underhood thermal application using SimLab as a preprocessor and AcuSolve as the solver. This is the second video in e-learning modules where SimLab wrappers is introduced. Inspection process and other alternative way to fix some imperfections on the geometry level are also outlined. Boolean operation on the surface mesh level will be used in this video to increase the resolution at some important phases. Picking up where we left off from the previous video, in this video we will start working on the engine, and this is where the wrapping workflow is introduced. The very first thing about the wrapping workflow is that we have to spend time defeaturing and delete all of the bolts and small holes in our parts. In this model, I'll pick out all of the bolts that is unnecessary in terms of modeling. Usually classified, so I simply click delete. But in real application, we have to spend time to go through individual holes and bolts. So there is holes here, here, and on the side of the models too. If we go into geometry, in features, when we have defeaturing features where we can identify and remove the holes. We can identify the holes by radius. I'll start going from 0 millimeters in diameters to 10 millimeters. I will select the engine, click apply. So you see that several holes have been removed already, but not quite there yet because we still have more on the engine block, on the side, and in the back too. I have tried 0 to 10 millimeters, and now I try 10 to 20. So these have been removed. We can go a little bit more than 20 millimeters. Now let's try 20 to 30. Okay. So we still have several details we have to defeature manually because we cannot simply always rely on the automatic tool. If we can isolate the engine block and the engine cover, we'll see that we need to defeature these 1, 2, 3, 4, and 8 holes in total on the engine cover, and then a few more on the engine block. We can do that by, instead of using holes, I will use details here. The input gonna be cat, and then I'll select all of the features that I would like to do. Select identical faces, and make sure that the 8 holes on the engine cover is selected. Then we'll do the same for the engine block too. We have one here that we missed. Now let's defeature these miscellaneous holes. Okay, if we display the engine, you see that there is several more details we would like to defeature, especially on this alternator. And one more in this miscellaneous part. We can use the feature details for this particular region. For this kind of situation, we cannot use the feature. Instead, because we are dealing with the wrapping workflow, we can create a part to covering up this cavity inside. There's many ways to do it, but in this example, I will use a cylinder to cover this opening. We'll snap into this vertex. So we need to move this cylinder into the engine part. And we're gonna do the same for this cavity here. Now we move the cylinder into the engine. We also need to pay attention to all of the openings, especially these two. Okay, I'll do the same where in this case, I can create a block, or I can create two cylinders. We use two cylinders. Move these two cylinders back into the engine again. In our problem description, on the exhaust manifold, there will be air from these two exhausts. The engines also take air into its system. We can create a sketch. I'll put an extrusion of 100 millimeters in diameters on the exhaust manifold. This is my sketch. I'll realize it as a single sheet body. I'll extrude it. Uh, 60 millimeters. If I enable the section cut in the Y normal direction, I want to push this cylinder a little bit inside so that I can Boolean subtract it from the manifold. I'll push it in by 40 millimeters. This is enough. Now we can do the Boolean subtract. The target body gonna be the exhaust, and the tools gonna be the cylinder will be created. Retains the tools in this case because we're gonna deal with the cylinder later stage of our workflow. So now we have the extrusion cut. We don't need this sketch anymore. We can delete it. And we're gonna do the same for the other exhaust. I will extrude this to 60 millimeters. I'll push it 40 millimeters. We can delete these two sketch. Now we also need to do the same where we would like to have like a flat surface on the engine intake. I will create a solid body that is contoured with this cavity. You can go into geometry and then I will create a fluid domain. But it's not really a fluid domain, we just use the fluid domain features to fill up this cavity. Make sure it's wetted surfaces and click apply. So there is a fluid domain that is created. We can rename it this as intake. I would like to move it backward. We turn on the X direction, section cut. We want to move it backward. Now let's try 50 millimeters. It looks okay. Now it's time to wrap the entire body. Wrappers. For the underhood cabin thermal workflow, we will choose external wrap. It's going to be tight wrap, and the element type we want it to be tri-3. If we select all solid body within the engine, I'll choose mesh size of 10 millimeters. For this initial wrapping, I will disable the create feature lines and create components. When the wrapping is complete, we'll see that there's a surface mesh body created, and all parts within the engine, all solid bodies within the engine will be merged into one. So when we analyze the first initial wrap, we need to look for a certain cavity created and weird placement of the elements, such as this one, where there is an annulus created connecting between the belt and the pulley. We also have weird connectivity within this alternator. Especially on the cable and the engine block. When we have weird connections and bridges and cavity like this, it means that we need to refine the mesh between these two parts. I will keep this as a reference, and I'll go back to the original engine and start placing surface mesh controls accordingly. So first of all, it's going to be the cable. I'll isolate it. In mesh control, I will place surface mesh control on the cables. I'll choose it at 4 millimeters. I'll make the angle per element as 15 degrees and click OK. Next is the alternator and then the belt. I'll select all of these surfaces on the alternator. I'll make this as 5 millimeters. Also do the same for the belt too. And then I'll place mesh control on the engine head right here. I'll place the surface mesh control on the top and the chamfer surrounding it. And I'll put it as 5 millimeters. The intake, I will also put the mesh control here. I'll put it as 5 millimeters. And I'll do the same for the exhaust. And lastly, I want to fix the cable because we have weird connection here, especially this region. I'll put the surface mesh and the cat body side by side. So I will recreate a rectangular block covering from this end to this region, somewhere in this region. I'll position it really well. And make it just large enough to cover the cavity. Move this into the engine. I also want to refine the fin right here. because there will be heat flux or constant temperature applied to this fin. So these have a lot of surfaces. I will disconnect them. Now let's change this to 25 to see if it's better. No, it's not. Let's do 15. Okay, there we go. We can select all of the wedges in here. If it's too much, we can reduce it further to 10. Okay, so this is exactly what we want. Because we're gonna place boundary condition on 272 surfaces, in case we don't want to do that again. In the wrapping workflow, I will detach it into a separate body. And then I'll place surface mesh control on that detached body. We can create body from faces. We can simply remove from the parent body. And this gonna be called engine fin. Now we can isolate this engine fin body. And I'll place mesh control. Put this as engine fin at 5 millimeters. Click OK. Now we can start our wrapper. Go into wrap. I choose all of the parts in the engine. And I'll still put the mesh size of 10 millimeters, but this time I will create components. You'll see the difference between create components and not create components as I showed previously. When the wrapper is finished, when we have create components enabled, so instead of merging everything together like previously, so all parts will be separated like this. So comparing the two, we'll see that the one where we place surface mesh control is a lot better in terms of resolution, especially near the alternator and between the cable and the engine block, especially on the engine fin too. Okay, now we're gonna separate this engine fin. I will choose surface and then I will create a group, so that I don't have to select all of 200 and 156 faces again. I'll call it engine fin. I will also do the same for the exhaust. Exhaust 1. These are exhaust 2. So the exhaust faces is not really high resolution. I'll show you how to resolve this a little bit. But let's deselect these faces. Click update. We'll do the same for the other exhaust. Because we also need to apply constant temperature on the engine block, I will grab the engine block, click isolate, and I'll create a surface group control. The same with the exhaust manifold. Okay. So there is a little surface here. It should belong to the engine fin, like that. Click update. Okay. Now we're gonna merge everything together. So you see that our surface group control is still remain. Circling back into the engine air intake and the exhaust right here, you see that these they don't have a great refinement here. In the next few steps, I will show you exactly how we resolve this. So first of all, let's start with this one. I will grab the sketch for this exhaust. Let's change it to yellow. Put it on the Y normal direction section cut. I'll kind of like move it backward. Make sure that there is maybe at least 3 elements from this edge right here is reserved. Put it right here. And you will see that there is a protrusion right here. Now we move that so that is kind of like slot into this volume here. And I also want to make sure that the cylinder sit extremely flush with these elements. You see it's not quite flush yet, so I will move it outward again. Try to position it to be in the perfect way. Okay. Now I'm gonna surface mesh this. Previously I put the surface mesh refinement here as 5 millimeters. So I will mesh this cylinder also as 5 millimeters. Okay, I will move this, put it here. Now I will connect the cylinder with our unit. So we combine. And we don't want to retain any internal faces here. And make sure that local remesh is enabled. When the Boolean operation is done, you see that we still remain the cylinder. But we have a lot better resolution on this face. When we are done, we can simply merge it together. I'll call this as unit. And we're gonna repeat the same step on this side. Make sure there is at least 3 or 4 elements from this lip right here, so that the battery layers can be inflated properly. And we also want to make sure that it sits flush. So I'm going to move it outward again. Try to position it perfectly. So there's protrusion outside. We move it so that it sits within this volume. Like that. Then I'm gonna do the surface meshing. Then the Boolean operation. The input body is gonna be mesh. And we don't want to retain any internal interfaces for this operation. Make sure you have local remesh enabled. Once the operation is done, we have a really high definition of the exhaust. Now we can simply merge them together into one part. I'll rename it again to unit. We're gonna do the same thing for the engine intake. I'm gonna grab the intake. Put the section cut on the X normal direction. I will move it a little bit forward so that it sits flush with these elements. Like that. And we don't really have to care anything about this. We only need to make sure that this flat surface is positioned correctly for the Boolean operation. Okay, I'm going to surface mesh it. And it's 5 millimeters. The same mesh control I put in the surrounding faces. Okay, now we're going to do the Boolean. Combine between the intake and the unit. So if we enable the section cut, you see that the intake surface is flat, which is extremely beneficial for the solver when we set the boundary condition later. Merge them. I'll create a face group for this surface. I'll call it engine intake. And I will call, we have the exhaust right here, but we don't have the face group for these faces yet. Click apply. At this point of the workflow, we have completed the engine, and we have completed the canopy, the radiator, and the MRF region. I will move the engine into our part and delete this trial wrap. Then I'll rename this as engine, and then this is gonna be my canopy. In the next video, I will combine all of the parts available here and create a big fluid domain surrounding.